Molded Fiberglass is ready to partner with you on your next renewable energy project, from concept to power up. Here's a quick look at what we can do for you.
MFG has been on the leading edge of manufacturing for the wind energy industry ever since we produced our first fiberglass composite blades in 1985. Since then, MFG has produced tens of thousands of blades, spinners, nacelles, and other fiberglass composite parts for installation in North America and around the world. Many of the composites for wind energy technology have been developed at our MFG Texas and MFG West facilities. Our 16-acre Texas plant, located just north of Dallas, has 155,000 square feet of production space, producing both epoxy and polyester blades. Located in Southern California, teammates at MFG West have researched and developed many advanced material applications in the wind energy field, including the production of the first epoxy blades ever placed into service in the U.S.
We have been on the cutting edge here at MFG West. We built a composite out of woven fabric and out of epoxy resin. That became our layup schedule along with balsa wood, so we could take out a lot of the thickness on the blade structure. I just thought it was a new market and a great opportunity, and it was an opportunity to grow, and that's what we needed at MFG West.
This innovation continues today as MFG research scientists work to enhance the manufacturing process with state-of-the-art design and development of the next generation of wind turbine blades and nacelles, plus the first of its kind utility-scale compression molded spinner.
We took the spinner to a new technology and we did a closed molding. The spinner is currently being launched in our Ashtabula, Ohio operations. The compression molded spinner offers one of the biggest advantages besides economics is the quantity that you can get off the mold and the speed you can do it. The blade process that we run is an infusion process. These parts are 30, 40 meters long and growing, and to hold the tolerance from part to part and still make sure that we have all the dimensions right, all the physicals right, is very demanding. The infusion process allows us to have a much better quality product and more reproducible than using a hand layup system or other types of processes for such large parts.
To fully support large customer strategies and to maximize our clients' production and costing goals, Molded Fiberglass has established manufacturing sites near where our customers need the product, such as our state-of-the-art 320,000 square foot wind turbine blade plant in South Dakota.
Hauling the longer blades over our highways. A 1.5 megawatt blade costs approximately $7.50 a mile to transport it. The 2.5 megawatt or the 48 to 50 meters, they'll approach $15 a mile. So having our factory built close to the wind farms gives us somewhat of a strategic advantage, and it's also a desire of our customers.
When we were originally looking at the facility layout for this site, one of the things we wanted to do is look at opportunities for automation. Two areas that we focused in on were the cutting and drilling of a wind turbine blade. The other area was the painting of a blade. In the cutting and drilling, it has a lot of very tightly toleranced operations, and robotics seemed to afford an opportunity where we would have a more repeatable process. The area of painting, we looked at the high level of labor and labor costs associated with that.
To paint robotically, it allows us to put the paint on in the specified areas to the required thicknesses and achieve a smooth, consistent finish from blade to blade. This would be a lot more difficult in a hand application. It would require a lot more paint, and we would lose the consistency from part to part.